So let's now take a look at what nonlinear functions can look like. So functions can be categorized as linear, or they can be categorized as nonlinear. So let's zoom in here. Nonlinear graphs, there's so very many options. And the nonlinear business comes from a variable rate of change. And when I use the word variable in this context, it doesn't mean like an X or a Y or some other letter. It means that the rate of change itself is being inconsistent. The rate of change is changing. It varies. It's not consistent or constant. And that's what causes the graph itself to be nonlinear. So some options that we have right here could be this inversely proportional situation. Okay, they're not lines, but that situation, those do not ever cross those X and Y axes, which is still passing the vertical line test, and that's why that is still a function. If it's a quadratic situation, it could look like this, U-shaped parabola. Or if we have a piecewise function, it could look like this kind of stuff. I mean, it could be all kinds of different things there. Now, again, when it comes to equations, there's all kinds of potential possibilities here. So there's a couple of things that we need to watch out for. One is exponents on your variables. If it's on a constant number, that doesn't matter. We can evaluate that. But if it's on an exponent, if the exponent is on a variable, then that's going to make it a nonlinear graph, nonlinear function. If we are dividing by x, or another way to phrase that would be that x is in the denominator of the fraction, okay? If it's a numerator, that doesn't matter. Only if it's a denominator will you get a nonlinear function. In third situation, where x itself is the exponent, that would be an exponential function. Okay. So I'm going to get some real specific examples here. Y equals x squared. That's going to match this middle graph up there. Y equals x cubed plus x plus 2. Those aren't like terms, and we can add those together. X cubed is going to be a nonlinear graph. Y equals 24 divided by x. That's actually going to match up with that first graph there. Y is the absolute value of x. That's going to be a different graph. It's going to give you a V-shaped graph. Y equals 3 to the x power. That's going to give you an exponential graph. Here's a very specific one. 49 equals y plus 1 squared plus x plus 3 squared. And if I evaluated that, that x would become squared, and that's going to be a nonlinear graph. In a table, let's say we have 0 and 0, and 1 and 1, and 2 and 4, 3, 9, 4, 16. This variable rate of change is going to stand out. So to find the rate of change, find your y differences. Find your x differences. And then write that as a ratio of y differences to x differences. So we've got 1 to 1, 3 to 1, 5 to 1, 7 to 1. And this will simplify to 1, 3, 5, and 7. We've got all kinds of different slopes going on here. Your slope is inconsistent or variable. And that's what's going to make this a nonlinear table, nonlinear representation of a table. For a verbal situation, things that you would need to watch out for would be area. Area is x squared. So that's going to be nonlinear. Volume, x cubed, nonlinear. Exponential growth or decay, and or decay. Both of those will be an exponential situation. And specifically there, we could list if it says it doubles every time, or it triples every time. That would be your factor there. Or it cuts in half every time. All right, all of those are situations that will give you a non-linear function. So now we've got that part filled out. Next, we'll compare relations with functions.